Continuing with Unit 3 review, Lesson 2 is on the coordinate plane, symmetry, and distance. So here in example 1, we're going to look at how to graph or plot points in the coordinate plane. But before we do that, let's take a look at some of the components of the coordinate plane. And of course, if we look at it, we can see that there's two axes. The horizontal axis is our x-axis, and the vertical axis is the y-axis. Where they intersect is called the origin at 0, 0. Now also, as we can see, the x-axis and the y-axis split the coordinate plane into 5 sections or quadrants. So let's label those quadrants. The top right one, the one we're most familiar with, where the x and the y coordinates are both positive, is quadrant 1. And then we label counterclockwise, so we're going to go to the left. The top left quadrant is the second quadrant. The bottom left quadrant is the third quadrant. And the bottom right quadrant's the fourth quadrant. So let's graph those 4 ordered pairs there in example 1. The first one is 6, -2. So looking at the ordered pair, the first coordinate, the x-coordinate, is a +6. And reminder, our horizontal axis is the x-axis. So what that means with the +6 is we're going to start from the origin and we're going to go to the right 6 units. And then, since the y-coordinate is a -2 and our vertical axis is the y-axis, we're going to go down 2 units. So again, to graph that ordered pair, we're going to go to the right 6 units and then down 2 units for the point 6, -2. The second one is -4, 6. So again, the x-coordinate's -4. So from the origin, we'll go to the left 4 units. The y-coordinate's a +6, so we'll go up 6 units. Number 3, -8, -2. The x-coordinate's a -8. The y-coordinate is a -2. So from the origin, we will go to the left 8 units and then down 2 units. -8, -2. And finally, number 4, 0, 5. This is an interesting case because the x-coordinate is 0. So we will not go left or right. The y-coordinate is +5. So from the origin, we will only go up 5 units. And label it 0, 5. For the second part, it says, describe how to graph the point -8, -2 on the coordinate plane. For graphing any point, we always start at the origin. Which is the point 0, 0, the x and y-axis intersect. And then, since the x-coordinate is a -8, we're going to move to the left 8 units. And since the y-coordinate is -2, we'll go down 2 units.
Example number 2 says, to name the ordered pair that is a reflection of each point across the x-axis. Now, earlier in the year, you discovered the relationship between a point and its reflection across the x-axis. However, it's always good to visualize it too. Right? So what we can do is we can first start by drawing a coordinate plane. Doesn't have to be perfect. Of course, the intersection of the x-axis and the y-axis, that's called our origin. Our first ordered pair is 8, 2. That means our x-coordinate is 8, our y-coordinate is 2. That means we start at the origin, we move right in the positive direction, and then up 2. That point is 8, 2. When you reflect across the x-axis, we need to figure out what is the reflection from our point down to the x-axis. Well, from 8, 2 to the x-axis, that's a distance of 2. A reflection would go 2 units down. So our reflection would be somewhere right about here. That means we would start at the origin, we'd go right 8 and then down 2. That point is 8, negative 2. Continuing to number 2, negative 7, 3 means you start at the origin, you go left 7, and then up 3. That's negative 7, 3. Again, if we're going to cross the x-axis here, we need to count 1, 2, 3 units down to our x-axis, and then go 3 more. So our reflection will be right about here. That's negative 7, negative 3. Based on these two examples, you can see that when you have a point reflected across the x-axis, the x-coordinate stays the same, and the y-coordinate becomes its opposite. Continuing to numbers 3 and 4, it says name the ordered pair that is a reflection of each point across the y-axis in this case. So number 3, we have the point negative 4, negative 8. That means we start at the origin, we go left 4, and then down 8. So if we were to cross the y-axis this time, that means we would have to figure out what is the distance from our point negative 4, negative 8 to the y-axis. I know that from negative 4 to my y-axis, that's a distance of 4. So I have to travel 4 more to the right. So the reflection, it looks like I would start at the origin. I would go right 4, down 4. So that's positive 4, negative 8. And then moving to number 4, 6, negative 5 means I start at the origin, I go right 6, and then down 5. So that's 6, negative 5. When I cross my y-axis here, I know the distance from 6, negative 5 to my y-axis is 6. So I have to go 6 over. My new ordered pair is negative 6, negative 5. Similarly to questions 1 and 2, you can see that the relationship between a ordered pair and the reflection of each point across the y-axis, we know that the x-coordinate becomes the opposite and the y-coordinate stays the same.
Example 3, perimeter and area on the coordinate plane. The coordinates of the vertices of a rectangle are negative 2, 3, 4, 3, 4, negative 4, and negative 2, negative 4. What are the dimensions of the rectangle? So in order to find the perimeter and the area of this rectangle, I must first plot the points on my coordinate plane, connect the dots, and form my rectangle and work from there. So I'm going to go ahead and do that right now. Negative 2, 3 is 2 to the left of 0 and 3 up. And I'm going to label each of my points as well. 4, 3 is 4 to the right of 0 and 3 up. 4, negative 4 is 4 to the right of 0 and 4 down. And my last point is negative 2, negative 4, which is 2 to the left of 0 and 4 down. Okay, so now I can go right ahead and connect my dots to make my rectangle. And as you can see, it is a rectangle because the opposite sides are the same length. And now I can figure out the lengths of each of these sides, the opposite sides, and work from there. So as we can see, we can count our units. 1, 2, 3, 4, 5, 6, 7. We have 7 units on this side. And then we can also count 1, 2, 3, 4, 5, 6. We have 6 units here. And so now we're ready to find our area. We have a 6 unit by 7 unit rectangle. And so let's go ahead and apply the formula for area of a rectangle. Area is base times height. Area equals 6 times 7. So we know our area equals 42 units squared. Okay. Now we're going to go ahead and figure out the perimeter of the rectangle. Now we know that perimeter is the distance around our rectangle. And so in knowing that, we can see that by labeling these other sides, we can add up all our sides. So we have 7 plus 7 plus 6 plus 6, and that's going to get us our perimeter. And we can clearly see we are actually adding 14 plus 12, and our perimeter is 26 units. So we have now found both the area and the perimeter of the rectangle.